going to go over the process of what goes into something like that. Like, how do we take our idea in our head or on our paper and actually build it so that it could be 3D printed, and obviously so that it works, because that's the key thing. So anytime we do this, we want to get it as accurate as possible to what we're going to be dealing with. So the example I showed last time was a little wire organizer, so I'm just going to do that, just so you can see that same process. In order for me to get that set up, I obviously need to know like what kind of wires I'm going with. If I have my power cable wire, that's pretty thick, and that may be too thick of a wire for like a USB or something. So I need to obviously keep those things in mind. I'm going to use, whoops, where's that cable that I had right here? So I have a USB cable right here, and this is the one I'm going to kind of fashion the size of it of. And if I go a little bit smaller than that, then that should be fine. Ideally, this is going to be set up so that for my car or my whatever, I can use USBs like this, or ones for my phone chargers or whatever. So I grab a ruler. You guys are familiar with rulers, right? Yes, cool. And if you're not sure how to read one, there's, I'm sure, a YouTube video on it. You want to figure out how wide or how big your item is. So for this, I'm lining it up to the number 1, and I see that this is about 1/8 of an inch thick, okay? Now if you have your phone, and let's say you're making a phone holder or you're making a whatever, you want to grab that same item and you want to measure it. So same thing, you line it up and you measure it. If it's like in my case, if I measured it without the phone holder and I measured it with the phone holder, 2 different sizes. If I'm making something I want to fit perfectly in there, that counts, okay? So this phone holder is like 6, I'm starting at the 1. It's like 6 5/8. So I would go 6 5/8 for that, okay? If I need thickness, if I need whatever, all of those things I need to consider. So the wire thing that I'm doing, 1/8 of an inch is how wide that cable is. Now that's 1/8 of an inch. Maya's units, if you remember from when we did stuff with Unreal, is centimeters, okay? So if I go to my little running man being chased by a gear and I go to my settings, I can change this from centimeters to millimeters to inches to feet to whatever it is, right? So if I set this to inches, and then let's say I created a cylinder. This cylinder right here, I need to put to 1/8 of an inch thick. So off the top of your head, do you know what 1/8 of an inch is in decimal point? No? 0.125. You guys are so horrible. All right, so that's 0.125. Now I typed that in here, but that means nothing to Maya because Maya is using several different areas of where that number actually means something. So I can't rely on just typing in a number here to get that, okay? Especially if you look at this, this is not a uniform size. The height of this is definitely higher than the width, okay? If I go to Create, Measure Tools, and I go to a Distance tool, I'm going to switch to my front view, whoops, or side view, and I'm just going to hold down V and snap a point there, still holding V, snap a point there. So this gives me the height of my item. Now if this item, if these locators didn't snap to the exact spot, I'm going to make these smaller so you can see it. There you go. If these didn't snap to the exact spot that I connected them to, like let's say it snapped onto this side, obviously that's going to give me a different measurement than I'm intending, right? Because I'm trying to figure out the height. So I need to make sure that they're perfectly lined up straight-wise, and that's 0.25, which is fine because that's not what I'm interested in anyway. I'm more interested in how wide is this. So I snap it over to that direction using the V key again to get it straight across. So this is 0.25, okay? So this must be square, but for whatever reason it just doesn't look perfectly square. So I need this to be 0.125. Now the reason it does this is because way down here under my poly cylinder, there's a radius of 1, a height of 2. So if the radius is 1, my diameter, which is double your radius, is 0.5. Okay, so now this should be the correct width. There and there. So now this is 0.125. Okay. You can also do this. So if I say I have something that is 0.125 inches, it's 0.3175 centimeters. So if I was working in centimeters, I could do that too. On your phone, same thing. If it's 7 inches, I could stick to centimeters, and then it would just be 17.78 centimeters. Just stuff to keep in mind, okay? Cool. So I need to know how big this is. Now this here represents the thickness of my cable. That's all it does. If my cable is that thick, I'm basically creating a C shape for the cable to slide into, so that shape there cannot be smaller than 0.125. And if it is 0.125, that thickness of cable is as thick as it's going to fit inside there. So if I had something that was even, a hair bigger, it wouldn't fit. So stuff to consider. I think that's going to be fine because I think most of my cables anyway are pretty, they're smaller than that one, okay? If I'm concerned about it, I'm not fully sure, I may make this 0.128 or something. Just so it's a little bit more, 135, there we go. It's a little bit bigger. That way for sure that cable will fit, and then for sure I'll have other stuff. Now the layout for this is going to be, just so you can see it from a top view. So this is just layout. I'm not using this to model. I'm just for sizing purposes, or for what it's going to look like purposes. So I'm basically creating a channel right here, and then there will be a bigger opening back there. Not that big though. Okay, so something like this. So I'll have an opening here, and then an opening there that the cable can sit in, so that when the cable is not being used, it's just kind of like resting inside that spot. All right. So that's my cable. Let's say I have 2 of these, like so, or even 4 of them. I think 4 might be a good number. I have 4 USB ports on here. All right, so I'm just going to group this for ease of moving purposes. I'm going to center the pivot, and then I'm going to hold down X and snap it there. All right, so that's perfectly where that needs to be lined up. Then I'm going to go and create a plane. And this plane is going to be what I'm going to use as my initial shape. So like, how big do I want this item to be? So let's say, pretty close to the size of that. So that's good there. All right, so I'm just going to pull this back a bit, like so. And that works. Okay, maybe it's a bit narrower like this, because the cables don't need to stick out too much, right? They just need to kind of sit inside there. And this is going to be like halfway through or so, like that. All right, cool. So now the cable is rounded, but my holes do not need to be rounded. They can be square, they can be rounded, it doesn't matter. So I'm going to add some more divisions in here. So I'm just going to grab my width. Nope. I'm going to grab my height. There we go. And I'm basically going to double this, because if I look at where these holes line up, you can see where these 2 line up perfectly with those 2 and those 2 and those 2. So it gives me a pretty close estimate as to how far apart those things are. I could even maybe make this, nope, I can't make that smaller. Maybe I'll go with 30. Nope. I'm trying to find something that makes my job just a bit easier to select things. I think that should work out pretty good. Okay. Now it's definitely bigger than 0.125, but I can always scale those down and shrink it and do whatever. So maybe I'll even just go back to 20. All right, so I'm happy with that. So now what I'm going to do is just grab the faces and then delete here. So there's where my cable will enter the platform. Okay, so that's where it's going to enter the platform. And then once it gets inside here, I'm going to give it a little bit more room. Here we go. I'm going to give it a little bit more room like that. That way I have plenty of room for the cable to slide in before it actually locks into place. Now when I get here, I'm going to go a bit bigger. So now, just so you can see, when I do this, this is where the cable would actually sit inside there. Okay, so I'm going to just visually kind of look at that and see how big that is, see if I like the sizing of it. I do know that if I try to do that with this one, I'm going to bump into that one. And so that's going to create a big opening, so that's not going to work. I do want this to be a bit smaller. So maybe I'll insert, actually let me just grab this edge here. And I'm just going to add some bevels around it. That should be good. Okay. And that way I can basically go right to where those lines are at. And that'll make it easier for me to select what I need to select. So now my cable will slide into here, and then it'll just kind of like wedge itself into that area. Okay. If I'm concerned about it going maybe too far, I can always grab these, and I could just scale those in too, and now they won't go that far, right? Or even maybe I went too far back. Let me go a little bit less far back. So I'll go here, 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 here. Like that might be good there. I think I like that. All right. So now I'm going to do the same thing on these. So you can see I'm pretty not committed to anything I've already designed. It's basically just kind of like throwing some stuff up there and seeing what these shapes are going to look like. All right. So that looks pretty decent as far as what that is. So that's the base of it. Okay. This is the functional part of this. If this part isn't set up right, there's no point in me even continuing on to the rest of it, because then that's the whole purpose is gone, okay? If I need to adjust any of these, like let's say, like I said, I want to scale these in, I can grab all of these and then just scale that in. Now as I scale this one in, you'll see that these other ones don't scale in too. So a couple things I can do. One is I can just kind of say, well, that's close enough here. I'll grab these points. Oops, not that one. Say that's close enough there. Deselect these, close enough here, and so on, right? So I can do that. That's definitely a possibility. Now, pretending that we can't be that inaccurate with it, and we need to be a little bit more precise, what I can do is I can take one of the shapes that is working out good and then use that as my template for the other ones, okay? So let's say that I like the way this one looks right here. So I'm going to take this. That should be good, okay? And I'm going to delete everything else. Okay, then I'm going to put my pivot right here. I'm going to duplicate, and I'm going to negative scale it. So I go to the Z direction and flip it over. And so now I just have two of these. Now just for sizing purposes or whatever, you'll see that it's a bit off. Okay, this channel right here that comes down the middle, it only is on one side. Here where I duplicated it, now I have like two of these. Okay, so I'm going to delete this channel down the middle. And then I'm going to move my pivot again, and then snap it again. Okay, so now that is the correct size. Boom. Okay, so now those are perfect. Now I need to put them together because right now they're two separate pieces. So I go to Mesh, I say Combine, and now they're together. Now in Maya, just because we've combined something doesn't mean that they're actually joined. And if I go to my vertices and I look at the vertice, you'll see that that vertex where they were touching are not combined. So I go to Edit Mesh and I say Merge. And now they's merged. Okay, now I can do the same thing for that other side to get that to go. Maya also has another tool though which will help us out. So that whole process that I did where I deleted half of it, I flipped it over and then merged things together, Maya has under the mesh, it has a mirroring tool. So it'll actually mirror the other side of this for me. I just have to tell it which direction. So if I look at this axis, it's going to go in the positive Z direction. So I go to Z, I say positive, and then I say mirror. You'll see that it shortened this one a bit. That's no big deal because I can move this over. Now I'm going to move it over until it looks like it fits correctly. That looks like it fits correctly. Maybe not. Let me see. No, that's right. For whatever reason, it's merging these two together. It's fine. It fits. Good. Okay. So now this setup here is the exact same setup across all four of those. Again, for something like this, it's not a huge deal if each one of these is a separate piece. They can have a little bit of wiggle room, but if there's a case where I need it to be perfect, then that is not the case. So as an example, hold on, it just came off. Nope. So this fits a little bit too well together. There we go. So this is an apple, this is a handle, and the handle has to fit perfectly inside there in order for this thing to function correctly. So if that wasn't lined up right, the apple does not fit in, or the handle does not fit inside the apple. For something like this, if the cable is a little bit off or a little bit, doesn't fit perfectly, it's not a huge deal. Okay? So now that I have my base shape for this, and I duplicate this a lot, because what I want to do is, as I'm building this, I may screw up. Okay, it happens all the time, sizes aren't right, whatever. I want to be able to go back to one of my original ones. So I'm always duplicating my shapes. So now that I have this, I have to give it some 3D aspects, because right now it's just flat. So I'm just going to extrude and give it some thickness. And then that's going to be how thick the item is. Now remember, we have inches, so this is 0.0291 inches, which is like super thin. It'll probably break off. So I'm going to make this maybe like 0.25 inches, which should be plenty big. Now that is weird that's happening there. See, I told you stuff happens. So let's do this again. That. I'm going to go back to Edit Mesh and Merge. I don't think something merged is what happened. All right, so I'm going to extrude again, 0.25. Oops, not that. Thickness. There we go. That's better. Okay. So now I'm going to double check with my measuring tool, which is another thing that I will do quite often. Hold V, snap to the corner, hold V, snap to the corner. Yes, it's definitely 0.25 inches. Cool. Okay, so this opening here is 0.125 inches, and then this is the height of this is 0.25. So that should be pretty decent. Like 0.25 is, it's about that thick from the one. So right between my fingers, that's about how thick that's going to be. So that should be a pretty decent size. Now I need this to clip onto something. So if you remember from what I talked about before, I wanted to create some way that this would actually like latch onto another object, like this desk. So because I'm using the desk, I need to figure out how tall the desk is. So this is about an inch thick board. It's pretty thick. So I'm going to create another cube, and that should be about an inch. That should be an inch. Okay, so this is a board. This is my wire holder. Somehow this has to clamp onto here. So I'm going to grab my vertices on the back of this and pull it back some. And basically I want this to rest on top of there. So I'm going to go here. I'm going to grab all my faces. I'm going to extrude. I'm going to pull it back. And it goes back about an inch. I probably can only go back about that much. That works. And then I'm going to grab all the faces in the bottom here to here. That's way too many faces. Let's try that again. This one all the way to that one. All right, I'm going to extrude this again. There we go. Pull that down. I'm going to get to the bottom of this, extrude again. And then I can grab all of, oops, not that. Grab all of these, extrude it, and pull that in too. All right, so now when I 3D print that, I should have a wire holder that will fit on the table edge here and kind of wedge itself because it's pretty tight, it's not loose. And then I can just feed cables through it and they will just sit right there. Okay. Now, as I look at this, this is very utilitarian. It works, or it should work, to print it to verify. Okay. So that should be, it'll organize my cables for me. I may want to add some design to this. I may want to add some fanciness to it. I have some areas that I could definitely do that. I'm going to scoot that over a little bit just to give me a little bit more room and a little bit of room. There we go. Okay. So like right here in the middle, there's plenty of areas where I may want to design something, add something, whatever it is. Inside Maya, I could just add edge loops. And then I can grab faces like this, and like this. And then I can extrude it. You know, and then just basically like model something that, you know, might look kind of neat on the front of it, okay? There's not a whole lot you can do as far as that, just kind of like screwing with the faces. There's definitely more stuff that we can do, okay? I'm going to undo that. Now let's say that I wanted to really get into this and really create something cool on top of this, not just having it like this, which is just really blocky. I'm also going to shrink the size of this bottom one. I think that might be up too much. There we go. Okay, I'm not screwing with this inner dimension. That area there has to stay that inch because that's where my desk is and that's where that's going to fit. Okay, so that's pretty close. I may have moved it just a slightly bit too much. There we go. Okay, so that should fit pretty good right there. All right, I'm satisfied with the way that looks. So what I'm going to do is I'm going to export this out as an OBJ, and I'm going to, I probably should make a project folder first. Sarcona 3D print in 2520. There we go. What? There we go. So there's my prototype. I'm going to export it out as an OBJ. And I'm going to go into a program called ZBrush. So ZBrush allows you to sculpt right onto the surface of an object. So the apple here is very easy. We could do that inside Maya, just kind of pushing and pulling points and tweaking them. The handle, in order to get all these ridges to kind of flow along the handle in all these different directions, I had to go into ZBrush for it in order for me to be able to do all of that, because ZBrush allows me to add like a trillion bajillion divisions. So if you're like me, you'll hate ZBrush until you played with it a bunch, and then you really like it. So a little thing comes up here, Lightbox, you just hide that. I'm going to import and find my model. So that should be on the P drive here, 20, 3D print, and there. So there's my OBJ. So here's my OBJ. ZBrush interface is kind of sucky if you've never played with it before. I'm going to click and drag my shape into this area and hold shift so that it snaps it straight up and down. Then I'm going to let go, and then I'm going to hit T. Okay? Now I can spin around the object. You don't have to hold any buttons. You just make sure you're off in the side. Oops. Let me import that again because I undid it. There we go. You make sure you're off to the side, and then you can drag around and see all the different pieces of your shape. If you hold Alt and you right-click and drag, you can pan around the object. If you hold Alt and you left-click and drag, it's still panning. If you hold Control and you right-click and drag, that zooms in and out. And left-click and drag does this little mask thing. Okay? It'll take you some time just to get used to that. So here is my clip, like that. Okay? So let's say that I want to put something on here. I'm going to hit Control D, and you'll see that this kind of rounds off that shape. So Control D is your basic smooth. It's like if I'm in Maya and I hit 3, that's what it's going to look like. Okay, so I really don't want to hit Control D yet. I'm going to go under my geometry here. I'm going to go down to my Dynamesh, and I'm just going to say Dynamesh. Okay, now what that does is without smoothing it out, without softening it, it added a bunch of divisions. So I'm going to hit undo again just so you can see that happen. I'm going to turn on my wireframe. There's my wireframe. I'm going to hit Dynamesh, and now I have all those divisions. Okay, so now ZBrush is awesome because it allows us to have literally like millions of divisions, and it won't slow down. Like it'll still spin around crazy quick, and then we can sculpt right on the surface whatever shapes we want. Okay, so if I want more divisions, like if this isn't enough, I can go over here to the resolution. So I'll turn Dynamesh off. I'll turn the resolution up, and then turn Dynamesh back on. And so now if I watch this number up here, that's how many divisions I'm going to have. Okay? Now, you'll notice that the divisions didn't go up at all. Even if I take this up further and I turn this off, turn this back on, you'll see we basically have the same amount of divisions. The Dynamesh is awesome because what it does is it basically figures out how many divisions do you need for this kind of surface. And it smartly creates those divisions. So don't worry about what I just did. I'll show you that in a second. But let's just say that I moved a piece of this surface really far away like that. And then I turn Dynamesh off and then I turn Dynamesh on. It'll rebuild that surface and add enough divisions to enable me to have divisions right in this area. If I'm in Maya and I grab a vertex and I pull it away and then I smooth it, Maya like squishes that surface back together. ZBrush says, okay, well you want more surface here, well I'll add more divisions. So now it added 4.457 million divisions just because I pulled that piece out. Okay, so if I look at the wireframe now, it's like super dense. Okay, that's way too many for what I need. Cool. So now let's get into some of the brushes that we can play with. So up here, these are all your brushes. Okay, there's like a million brushes you can play with inside here. Think of this like you're sculpting clay. Ignore modeling concepts. It's more like you're sculpting clay. So one of the tools you would typically use if you're using clay is like clay buildup. Okay, your focal shift is here, which is like the center softness outward. The draw size is right here. Your intensity of how far you're pulling or pushing is right there. And then I can just click and drag. Okay, so there's my first little piece of this. If I take my Z intensity up further, you'll see how much more it pulls it out. Okay, so you really want to be subtle with some of these things first. There we go, like that. Okay, if you want to, you can right click. Here's all those same buttons. Here's your clay buildup, here's your brush alpha and other stuff. You can also hit B and this will bring up all your brushes. Now let's say that I want the standard brush. I hit B, then I can hit S for standard. It's right there. And then there's a little hotkey right here, T, T. So once you get comfortable with ZBrush, you'll really just kind of know what the hotkeys are. It's like 3 hotkeys to get to any brush. Okay, and they all do something. So this brush here is the damn standard brush. It does that. This is clay buildup. It adds clay to stuff. This is your standard brush. It just kind of like moves the surface around. This is the pinching brush. It pinches pieces together. This is the inflate brush. It inflates stuff. Okay. So if you want to play around with ZBrush a little bit, you definitely can play around with ZBrush a little bit to add some sort of design. Now, one of the neat things about Dynamesh is that if I were to, let's just say I inflated this really far like this. Oops. So I inflate this like this, and I inflate that one like that. Okay? So if we were in Maya, those pieces would basically be separate pieces still. But in here, if I turn my Dynamesh off, then turn it back on, it'll actually weld all of this together and make one shape. So this item here, I could build the handle as one piece, build the apple as a separate piece, put them together, and then Dynamesh would automatically be able to blend all of this together. So then I could print this as one piece instead of 2. Now because I just did that, you'll see that up here, it's still thinking. ZBrush is an awesome program in that it rarely ever crashes and dies. Usually it just takes forever for stuff to happen, okay? So if you want to play around with this, you definitely can. Now it's all one piece. I'm going to hold Shift, and this is your smoother, and so I can smooth this out. Now, because it Dynameshed it again, there's 8 million divisions here. I'm going to take this down a bit. The hotkey for, instead of clicking Dynamesh off and on, you hold Control and you just drag into space, and it'll just rebuild it for you. It's still thinking. It's not going to crash. There we go. All right, so it gave me a little bit less divisions. Let me go a little bit smaller. I'm going to go to 480. No, It's still a lot. So it's basically saying in order to keep this shape, you need 6 point whatever. Turn that off and turn this really far down. There we go. So now that's definitely smoother. Okay, so I can smooth out this shape, I can tweak the shape, modify it, whatever. Bless you. Okay, so if you want to play with it, like I said, you definitely can play with the tools. I'm not going to go too much more into this except just that, okay? Just play around with the tools. I still don't want to screw with that center area because that's what's clamping to something. And I really shouldn't have screwed around with this because that's where my wires are going to go, and so now this is basically a useless tool. Once I'm done with it, I would just go back up here to export, and I would export this out as an OBJ and then bring it back into Maya. Okay, so export, whatever you're calling it, save, and then bring it back into Maya. Now, if I'm done with this, I'm happy with the way this shape is looking. A couple things I should do regardless is still put on some bevels. Let me isolate this shape so I can see. Come on. There we go. Actually, I'm just going to grab all my hard edges. So I'm going to go to my select constraints. Do the geometry angle something above 90, something below 90. Current and next and activate. So now when I marquee, I should get everything that's a 90-degree angle, which I do. So now I will add a bevel, add 2 segments. And what this will do is not only allow us to not have super sharp edges, but when we 3D print this, the support material will actually break off a lot easier. Then I'm going to look at the direction I want to print this. So there's not really a good direction. I mean, they're all going to be about the same. But I believe the solidest part would be that. Okay, having this part print first, and then going up to these other parts. Okay, so there's my piece. I'm going to freeze my transforms. There's no UVs needed on this. And then under File, I'm going to go to Send to Print Studio. Now what this does is it allows us to save what's called an STL file. The STL file is read by the 3D printer. The 3D printer is what prints the stuff. Okay, so I'm going to say Move to Build Surface. I'm going to leave it exactly how it showed up here. And then I'm just going to say Export Selected. And then when I do this, there, I'm going to call this what my name is, Sarcona underscore cable holder. Okay, so now inside of my 2520 folder, 3D print scenes, I should have this STL file that says Sarcona cable holder. Not today, probably Monday of next week. I'll show you down in the 3D Print Studio of how I take this file and then can load it onto the 3D printer and then have it go and actually print the items out. But that's it. So it's just a matter of, the hardest thing is just figuring out what you want to do and then how you're going to accomplish that. The modeling is typically the easy part. This thing here is going to be used actually for a torch. I think I showed that before. And eventually what's going to happen is these are going to be somehow mounted onto a wall. So this will be metal eventually. This will be metal as well. And then there will be this crown torch type thing that's on here. So how that mounts to the wall is obviously I have to consider, like, what are my options? And if that's something I'm going to be doing, maybe I look at the internet. Mount torch wall. So something like that I could definitely create. I would have to consider the fact that this apple is really big at the bottom. So something like this, it's hard to see on the projector, there's a ring. Basically, if this was tapered, the ring would fit right inside there, okay? So with the apple, it doesn't work. So that design couldn't work for this specific one. I could make it kind of work. I don't want anything like that, anything like that. You know, it has to be something that can be added to the wall, and then the torch can just kind of slide in. And I'm really not seeing anything in here that is just like, oh, that'll work. It's kind of weird. So eventually what I'm going to end up doing is something very similar to this, where on the wall it'll have this little holder where this will fit in, and then it'll slide down and like lock into place. Okay, so this part will be narrow, and then as it slides down, it's locking that main torch part in place. And this is not dried yet. So something like that, again, it's just kind of figuring out those basic shapes. First, create a rough shape of what that looks like. And then for something like this, I can use, come on. Oh, I'm in isolate mode, there we go. Nope. Oh, I'm still on my, that's what it is. I still have my select constraints. I have to reset this. There we go. So now I can extrude this out, delete the inside part, delete this outside part. And then something like this will be my starting point for how this little area is going to slide in, and then the torch will be able to slide down. And you'll notice I built this bottom one off of a plane. It makes it much easier than trying to deal with a cube. Because on a plane, I can basically just start taking these areas like this. Not that one. Make sure this is symmetrical, which it is now. There we go. Then I can extrude that area. I can pull it back. I can flatten it out. And then I can extrude this a little bit just to give it some thickness. Maybe I'll insert an edge loop right here, flatten that out. And then pull that down. So something like that is how that torch could attach to a wall, right? And then I would just have to have, obviously this has to attach to a wall somehow, so maybe like put holes in this later on. So maybe I would drill holes in this thing later on to get it to mount to a wall. Or something like this, I could actually use too. Eventually there's going to be a bunch of these, like 8 of them or so. I'll throw this on the floor. It's leaking. I may just use something like this as a way to create a case that these little slips will kind of slide into, and then each torch that's inside the case would fit right there too. Okay? So you have to think about all these things as far as like, what am I trying to accomplish? Start there. And then build around that as to what you want these things to look like. Once I have this circle and I know like that circle is working, then I can start to shape this however I want. I can, maybe shrink this in like that. Maybe I want to add a division in the middle. And then kind of pull that out some, maybe add a bevel. Right, so it's a little bit fancier than it was before. Maybe I go here and I pull this up, and then I pull it up even further, and then I grab these. So none of the stuff I'm doing right now is taking away from the functionality of it. It's just kind of like this is the new shape of it. Okay, so MCC built this, so Macomb Community College, boom. That way everyone knows. Right, this could also be mounted to the wall as well. Maybe I want to have a little piece in the bottom where when the torch is inside here, there's a little resting spot. So like it's not just floating in space, but there's something that's actually like holding onto it at the bottom. Right? It's like a little basketball hoop. Right, so something like that is how I would approach that. Now I haven't brought the torch model in as far as sizing, dimensioning, whatever. I need to do that at some point to make sure that this circle is far enough away from the wall that it doesn't collide with it. Because if it's, just use this helmet, if this is against this item like that and then it just doesn't slide down because it's hitting the wall, it does me no good. So you always have to make sure that you have at least a rough idea of where things are at. How big is the crown of it? How big is this? How big is that? How big is your phone if you're going to make a phone holder? How big is whatever it is that you're making? It's kind of a neat way to do that one. Okay. So your turn-in for this will be just that STL, and then we'll send it to print. The item obviously has to be small enough that we can print. We are limited to size, so something, you know, around 4 or 5 inches is typically like a good size. This is obviously way too big for that. Cool. Questions yet? Yes, sir. No, I haven't done a character. I've done like character heads here, and I've done little figures. I don't have any here, do I? No. I have little figures that I've done, but something any bigger, it would take forever. Even like those heads, those took about 4 hours each head. Yeah. Anything movable is tricky too because of just how is it moving and how are things connected. Just so we can kind of talk about that too in case you do want to add something. So we'll just pretend that this is one of our robot's side of his body. Let's say that I deleted these faces here, and then did that. All right. Okay, so that doesn't fit through there, which is perfectly fine. It's exactly what I want. But what I'm going to do is take those faces and extrude them, and then extrude them again, and then extrude it again, and then extrude it again. And then this has to be extruded too, so it has some thickness, otherwise it doesn't work. And you'll see that it's black, so this has to be mesh display reversed. There we go. Okay, so something like this, if I were to 3D print it, these pieces would print exactly like that. I would have this wall and then this little gear, and that gear would turn. So if I did have like a robot or something with an arm, I could do something like that. The issue is making sure that this is big enough so that that tiny pin area right here is not super tiny. Because like I showed before on those other ones, if it's too small, it'll just snap off and it won't work. Okay? And then stuff like this, all these little facets like that, that will also print. So you may not want any facets like that. If you hit 3, obviously it won't, oops. It'll look like it's smooth, but it won't actually be smooth. The 3D print does not read the 3, so you would actually have to add your bevels and then smooth this thing out. So I would go, let's say 0.2, 2, and then go to mesh and say smooth. There it is. And I would even add an extra division in here just so it's nice and smooth like that. Okay, so that's the part that I would print, or these two parts are the parts that I would print. And